Remember that GPT-3 that everyone was talking about? We all know what GPT can do, and in case you didn't, it can generate any sequence of text or code or even images, which is really impressive. But they have one big issue, among many others, is that they are big, like billions of parameters big. And what's amazing is they just keep on getting bigger. All these big corporations just keep on training these models to trillions of parameters, which is a problem because how will the general public train them? But more importantly, how expensive will it be to even deploy such a technology? Recently, DeepMind released a transformer architecture that works equally as good as GPT-3, but works faster. Now, this of course is not a groundbreaking innovation, but it's definitely a big leap forward to a more versatile language model. Here's how it works. The overall idea of the model is very similar to a GPT model. You pass in an input text, and the retro model generates a token that is most probable for that sequence. There are 4 main steps to this architecture. First, you take the input sequence and make it into a BERT embedding. You use those embeddings to find similar sentences from a database, and then you pass it onto an encoder to generate keys and values, which then is passed into a decoder to generate that specific token. Now this architecture brings 2 main benefits. 1, we're getting slightly more transparent model. 2, the overall parameter is smaller than a traditional GPT, while still being competitive to a GPT-3 model. To summarize the architecture in one line, you retrieve similar passages from a database for an input query, pass it onto a transformer encoder-decoder model to get the most probable output. Alright guys, this is Retro under 2 minutes. I really hope you guys found this informative. I will provide a link to a blog post that describes this architecture with even more details. Be sure to check out the actual paper if you're interested, or I will also provide a link to a GitHub repository that someone has implemented this model. Anyhow, that's it for me. Thank you guys.